John and Alice, can you observe the patterns on the floor? These patterns are made of polygons.
Polygons?
What are they?
A polygon is a simple closed figure made up of only line segments. Some polygons you already know are a triangle and a square. You can see that the floor designs are made up of quadrilaterals and octagons.
What is an octagon?
The octagon belongs to the family of polygons. It is a simple closed figure made up of 8 line segments. Come, let's learn more about polygons. First, we will learn how to classify polygons. So, how many varieties of polygons can we think of? Many. Can we say? Yes. Let's see how we can visualize different polygons. Let's start with a simple polygon, a triangle. A triangle has 3 sides and thus is a 3-sided polygon. If we cut the triangle at one vertex and add a side, it will become a 4-sided polygon, which is called a quadrilateral. Again, if we cut the quadrilateral at one vertex and add another side, it is a polygon of 5 sides, which is generally called a pentagon. In this manner, we can obtain a 6-sided polygon, a hexagon, a 7-sided polygon called a heptagon, and so on. If we have an n-sided polygon, it is called an n-gon. Take a look at the table to understand the classification of polygons according to the number of sides or vertices. Let us now learn what a diagonal of a polygon means. We know that each side of a polygon is connected by 2 consecutive vertices of the polygon. Now, we take 2 non-consecutive sides of a polygon and try to connect them. Let us consider vertex P. The consecutive vertices are Q and T. The rest of the vertices R and S are non-consecutive vertices. We connect the vertices P, R and P, S. These line segments are called diagonals. Therefore, we can conclude that a diagonal is a line segment that connects the non-consecutive vertices of a polygon. Alice and John, can you show the other diagonals of this polygon?
From vertex T to vertex Q and vertex R.
From vertex Q to vertex S and then to vertex T.
The diagonal from T and Q is already drawn. So, it is considered as a diagonal from Q to T. So we can conclude that a line drawn connecting 2 non-consecutive vertices of a polygon is called a diagonal. So, a diagonal in a polygon is drawn connecting 2 non-consecutive vertices. Now, let's look at this figure. It is a polygon in all respects. John, can you draw the diagonals for this polygon?
Here they are. But how to draw a diagonal between these non-consecutive vertices S and P?
It seems that the diagonal drawn between these points lie outside the figure. That's a good observation, John.
If a diagonal lies outside a polygon, then the polygon is called a concave polygon.
If all the diagonals lie inside the polygon, then the polygon is said to be a convex polygon.
Can we see some examples of convex and concave polygons?
Oh yes, definitely. Look at this polygon. How can we verify if this polygon is convex or concave? Let's start by drawing diagonals from vertex A to the non-consecutive vertices C, D, E, F and G. Similarly, we draw diagonals from vertex B to other non-consecutive vertices. Now, we draw diagonals from vertex E to other non-consecutive vertices G and H. Likewise, we draw diagonals from vertex F to other non-consecutive vertices. Now, observe that diagonals EG and FD lie outside the polygon. Therefore, this is a concave polygon. Now we will see 4 polygons. John and Alice, here are 4 polygons. Name them and identify if they are concave or convex polygons. Alice, you first.
The first polygon has 5 sides. So, this is a pentagon. Now, on drawing the diagonals, we see that all lie inside the polygon. Thus, it is a convex polygon.
Now, it's your turn, John.
This polygon has 5 sides. So, this is a pentagon. To check whether this polygon is convex or concave, I will draw the diagonals. One diagonal lies outside the polygon. So, this is a concave polygon.
The next polygon has 6 sides. So, this is a hexagon. Since 2 diagonals of this polygon are lying outside the figure, this hexagon is a concave polygon.
The fourth polygon is an octagon since it has 8 sides. All the diagonals lie inside the polygon. Therefore, this is a convex polygon.
Thus, 2 polygons are classified as convex and the other 2 as concave based on the position of their diagonals. Now let's differentiate between 2 polygons that have the same number of sides, based on the length of the sides and the measure of its angles. We have 2 polygons here. Alice, can you tell the difference between the polygons?
The number of sides is the same for both the polygons. However, it seems that the first polygon is quite different from the second.
How are they different, Alice?
Look at this polygon. Each side of the polygon is of the same length. Also, the measure of each angle is equal. On the other hand, in the first polygon, the lengths of the sides and the measure of the angles vary from each other.
Oh yes! Then how can we name these 2 polygons?
That's a good question, John. The polygon with equal sides and equal angles is called a regular polygon. The polygon with unequal sides and unequal angles is called an irregular polygon. To conclude, a regular polygon is equiangular and equilateral. If a polygon satisfies these 2 conditions, then it is said to be a regular polygon.
How do the words equiangular and equilateral connect to a regular polygon?
Okay. The word equiangular means the interior angles of the polygon are equal to one another. The word equilateral means the lengths of the sides are equal to one another. If a polygon needs to be called a regular polygon, then it should satisfy these 2 conditions. For example, take a rectangle. Here, the interior angles are equiangular, but the sides are not equal to each other. Therefore, it is an irregular polygon, whereas a square with all sides and angles equal is a regular polygon.